So here's a quick rundown of Atwoods. Now the objectives for the Atwoods Machine Lab, we're going to use Atwood's machine to measure the relationship between force and acceleration, and then you're going to graph this relationship. Now if you know Newton's second law, you may have a spoiler alert, but that's alright. We're going to do this anyway because that's... So this is Atwood's machine. It may look like a pulley, but looks can be deceiving. And what you're going to do, it has two masses hanging on it. This is what makes a difference. You have one mass here, one mass here. If mass 1 is greater than mass 2, this mass is going to drop. This mass is going to go up. It's going to cause them to accelerate, and they're going to accelerate at the same rate. Here I just put in the negative sign because one's going down, one's going up, but you can draw your diagram however you want. So if we look at this, this is a more in-depth look. Again, mass 1 is going to go down. We'll call this A, by mass 1 I meant mass 2, and this is mass 1. It's going to go up, and you can see that negative A1 equals A2. Now, look at your handout, and it'll actually go through this. But the important thing to note is that the mass difference between these accelerates. So the mass difference, and gravity, can't forget gravity, causes the acceleration. Causes your acceleration. And you can think about this, if these two are balanced, it's not going anywhere. But if this is really heavy, it's going to fall. So one important thing, you're going to measure very small masses and forces. So mass everything. Don't take anything for granted. And the other thing is have the more massive objects on the right, which makes sense because this is the mass that's going to fall. So mass everything, mass everything, and put the more massive object on the right. So let's talk about which mass is actually accelerating. It is the mass here, because it's going to go down. It's the second mass. It's the 10 grams you added. So we've got mass 1 plus mass 2 plus 10 grams. But there's another thing that's moving, and it's this pulley. And if you look, this spot goes around really fast. This spot does not. We'll talk about this later. And you get the mass of the pulley over 2 is what contributes to the mass being accelerated. So it's all this plus mass of the pulley over 2. We'll get to this later in the book. And this is your theoretical mass, and the mass of the pulley is what you're eventually going to solve for. All right, and here's a little spoiler. You will hit this, and it will go, and you will see the speed of science. And I don't want to give too much away here, so we're going to stop. But it's going to go down there. Now, one thing that I want you to tell you on this, you will always have 10 grams. So you have a 5 gram, a 2 gram, another 2 gram, and 1 gram. They total 10. You will always put all of these on either hanger. All right? So the total mass will always be 10 grams extra that you've added. But what this does mean is you'll start off with 10 grams and then 0. Then your next run, you'll have 9 grams and then 1 gram extra on the other, then 8 and 2. And you'll notice that if you're looking at these mass differences, here you have 10, here you have 8, here you have 6, all the way down to 2 grams. Now, also note that when you calculate newtons, put your masses in kilograms. So if we're looking at this, you've got this little mass. It is going to fall a distance delta y, and you can calculate acceleration from this. You will do this multiple times. You will have timing will always have plus or minus. Your fall distance, you will measure this multiple times, so you will have plus or minus. And then after you do this, timing all your sets, so repeat for all your masses, repeat for mass differences. Then, after you do that, you'll repeat and add the extra masses we've provided. And then you'll do this. So you'll wind up with 2 graphs. One graph for your original masses and one with the extra masses provided. So let's derive this real quick. You're calculating acceleration. You know that delta y, your y final, 0, y initial, whatever it happens to be. You know v naught y actually starts at rest, so you get negative equals 1 over half a t squared. Your acceleration is gravity, or acceleration due to gravity. That is a huge no-no. So a equals negative 9.8 meters per second squared. So you will get, and since this negative cancels here with that, you wind up with your end product being acceleration equals y initial 2y initial over t squared. And this is the magnitude of your acceleration. So when you're doing the error analysis for this lab, again, we always report it as your average plus or minus the max possible minus your average. So to get the max possible, it's going to be your maximum measurement for height and your minimum measurement for time. Because you did multiple trials, just take your minimum. So every acceleration will have a plus minus value. The final part of this is going to be your graph, and you know that the relationship between force and acceleration is F equals ma. Well, you have measured force. It's your accelerating force caused by the mass difference. You know your acceleration because you measure it. You are going to find this, which is your mass. So if we compare this to the formula, y equals mx plus b, you will note that your force is on the y-axis, acceleration is on the x-axis, and your slope should be your mass. And you use this to solve for the mass of the pulley. And that'll be your final comparison.